All right, so we're going to talk about Cyrus, and I want these pictures that are up on the screen right now. We've got these came out of Amanda's presentation, right? And this is the field types we're dealing with on that piece of ground. So we've got, those grass models, we got this decadent juniper, we've got the bitterbrush, those types of things. You guys get the picture of what we're actually looking at. So keep in mind, this is the map of that area, okay? And remember, we have these things in here that are sort of our values that are marked, the orchard, the guzzler, those types of things. And you can see where the burn unit boundary, the green line, is sort of cutting across these different field types. All right, so keep this kind of map in the back of your mind as we talk through the rest of this. So in IFTDIS, what we want to do, the goal here is to take what we did with the prescription and put it into IFTDIS and be able to look at those outputs on the map. Okay, you guys did that in Behave, and you got the numbers in the table, but now we want to look at it spatially on the map. So in order to do that, we first have to look at our fuel models. Then we run fire behavior across those fuel models, and then we get to compare those things next to each other. That's sort of it in a nutshell. So what I'm going to do is I'm going to talk about this just a minute, then I'm going to demonstrate a few things. Then I'm going to turn you loose on that first exercise so you can click the buttons yourself. But the first thing I want to talk about is fuel models. And at least I want to get the conversation started because this generates typically a lot of questions. So when we look at fuel models, right, we know what's on the ground. We've got these pictures. We can see what's there. And if you're really familiar with this burn unit and you've walked around it, walked through it, you probably have a pretty good idea in your mind what fire behavior is going to look like under different conditions. And again, like Luwen said, I really like that she said this morning, the model, it's just a model. It's just showing you, it might reinforce what you already know. It might give you a really good picture. So when you sit down with that line officer or your hydrologist, say Brad was our hydrologist, and we needed to show him what this fire behavior was going to look like for some of the points of concern he had, it's a great way to show people maybe what you already know, or at least confirm what you already know. You might find some things that might surprise you. We'll see. But the first thing we have to do is verify our fuel models. And the reason we have to do this is the data that we're using in IFTDIS comes from Landfire. Okay, Landfire is a mapping program that started way back in the early 2000s to map all of the vegetation and fuels across the country. So we have a seamless coverage of vegetation and fuel models and all of the characteristics that go with those that covers our the lower 48 and Alaska, Hawaii, and actually Puerto Rico as well. But the way that Landfire is done basically is it uses satellite imagery, it uses remote sensing. Okay, so in order to do this at this large scale, that's how it has to be done, and it's verified by different means on the ground through plots and things like that. And they've gotten much better at it over time. But the most recent Landfire data that we get to use today that's sitting in IFTDIS and some of the other applications that are out there is from 2016. That's 5 years ago, right? It's 2021 now. So a lot of things have happened to vegetation over that 5 or 6 years. We've had wildfires, vegetation grows, it dies. We have fuels treatments that we do, it might get hit by bugs. Any number of things can cause a disturbance on the landscape. So the data that was acquired in 2016 might not actually be what's sitting on the ground today in 2021. So we have to check it and correct it and make it so it represents today's fuel model. Also, it could have just been mapped incorrectly. That's a remote sensing, it's a digital process. There's error, there's human error that can get thrown into that. So Landfire isn't perfect. It's a fabulous data set, but it's not perfect. And we, as the users of it, have to make sure it fits what we need and what we know on the ground. The goal is eventually for Landfire to map disturbance every year. They want to do an annual update to the Landfire data. So a wildfire that burned this summer, say the Dixie Fire in California, right now, if I were to look at the Landfire data in IFTDIS, that Dixie Fire won't be in there. Even a fire from last year, 2020, will not show up in the data. I have to put it in there myself to make sure it's being displayed on the map. okay? But eventually Landfire wants to get to an annual update where, say, for example, in January of whatever year, all of the fires from the previous year will show up in the data and you won't have to go in and correct it. You'll still have to check it, but you won't have to add those disturbances. So anyway, that's where they're headed with Landfire. Okay, so here's an example, and you're going to do this in IFTDIS in just a minute. But I want to show you some screenshots first. So what I did is in IFTDIS, I went and got the fuels data from 2014. And we're using the 2014 data. There is a 2016 data layer in there. We're not going to use that one. I don't think it did a very good job mapping this rangeland area. The 2014 data, I think, did a better job. So that's just my opinion. Whoever's working over in that area that maybe knows that patch of ground better might, they might choose otherwise. But for this exercise, we won't get into all the reasons, but we're using the 2014 data. And you can see I drew my box, which I got my landscape. You can see the burn unit boundary in here, which is that polygon. And then I ran a report on the whole square. So this whole square that's here. And you can see the breakdown of the fuels. So we have GR2, which is that grass model. And then we have this these two grass shrub models that are the dominant fuels on here. Okay, so that's what shows up in 2014. Now the pictures I just showed you show a whole bunch of really tall juniper, right? Real decadent juniper and really thick bitterbrush. Well, neither one of those actually fits in this GS model. That's not what those fuel models are. So does that make sense? Because what we need to do then is, because we know from looking at the pictures, we really need some shrub in there. We need these actual shrub models. So we need to change some of this. And in order to keep this exercise fairly simple, we decided just to go with 2 fuel models, mostly because it's easier to keep track of things. And as you're running these calculations, I think just having 2 makes it a little easier to have a discussion. You might have a landscape that's much more complex and has a lot of different fuel models in it. It just depends on where you are in the world. So what we did is I went in and I manually edited the fuels and said, nope, I don't want GS2, I want SH5. And so we're going to work through IFTDIS, and I'm going to show you how to do that in IFTDIS to change them. Okay, so that's the difference. You can see the difference there in just that report on the fuels. Now, the reason this is super important is because when we look at fire behavior, if I run a basic fire behavior run on that 2014 data before I made any changes, because of all that grass and grass shrub model, flame lengths in that fuel model are generally pretty low. So depending on what your inputs are, right? So if I were to just run that and not make any changes, my flame lengths are only going to be like 1 foot tall. Well, we know from those pictures that juniper and bitterbrush is going to produce a heck of a lot bigger flame length than that. So I need to correct my fuel model so I get the proper fire behavior. That's really the bottom line with this, is I got to get the fire behavior that I'm expecting. So by doing that, on this right-hand side, I changed that to the SH5, that shrub model. And now you can see we added in a whole bunch of flame lengths that are between 8 and 11 feet. That makes a little more sense to me if I'm running just sort of an average fire behavior run and I get these higher flame lengths. Okay, now I feel better about that. Okay, so now I can run with that as far as that change I made, and I can do the rest of my prescription now that I feel good about my fuel models. Okay, so that's the first part of this, is editing your landscape.